Welcome back, everyone. Today we're going to have a workshop on exponential operations. For this topic, we have three objectives, and the first objective says that I can simplify numeric radical expressions involving square roots. So let us begin. For our first example, we have square root of 48, and how we do this is we're going to do the factor tree. No matter how you factor out 48, we are all going to reach the same exact answers at the very end for as long as you don't do 1 times 48 because you're going to just go in circles. So I did mine as 2 times 24, and as you can see, 24 is still factorable. So you're going to keep on going until you cannot anymore factor out because you just have prime factors. So I did my 24 as 2 times 12, and then again 12 can be factored out. And still 6 is not prime, so you're going to keep on going. Now that you have all these prime factors, you're now going to go back and set up your radicals such as this. Please make sure that you don't write inside 6, 12, and 24 because they are not prime numbers. It might help for you to generate your first 5 primes just to have an idea on how your factor tree would look like. In this case, I have generated it for you. The first 5 primes are 2, 3, 5, 7, and 11. Please understand that prime numbers are numbers that have only 2 factors, which are itself and 1. So let's just have a quick review on this one. Why did I not include 9? 9, other than 9 times 1, has another factor, which are 3 and 3. So because of that, then 9 is not considered prime. So anyways, let's go back to this one. So now that you have this, we're going to look for pairs. So that's a pair. Circle it and put an arrow, meaning to say that will go out. This is a pair. It will go out. And once it goes out, it is going to be multiplied and it will just turn into one piece of 2. So this piece of 2 right here is for that one, and this piece of 2 right here is for this 2 pairs right here. So again, look for pairs, but whenever they go out of the radical, they will just turn into one piece because you're getting the root. The 3 has no pair, so it stays inside. So therefore, for your square root of 48, your final answer is 4 square root of 3, which is letter A. Example number 2, use the same process as example number 1. So in this case, 32 can be factored out by 2 times 16. Again, no matter how you break 32, it's going to lead us to the same final answer. Just don't do it with 1 times 32 because again, you will go in circles. After factoring out 32 with 2 times 16, I'm now going to, 2 is now prime, and now I'm going to factor out 16 with 2 times 8, and again 2 is prime. So now we are factoring out 8 with 2 times 4, and your last and final step is to factor out 4 with 2 times 2. After that, you're going to go back to your radical with all the prime factors inside, which are all these 2's. So 4, 8, and 16 are not there because they aren't prime. So now you're going to do the strategy of looking for pairs. So we are going to look for pairs, and that will turn to one piece of 2. This will now turn to one piece of 2. We're getting the roots, and so because of that, those pairs will go out of the radical sign. The last 2 has no pair, so it will stay inside, and this other 2 will be multiplied, meaning to say your final answer is letter B, which is 4 square root of 2. Okay, moving on, objective number 2 now. I can simplify numeric and algebraic expressions using the laws of exponents, including integral exponents. For our first example, it's a simplify a to the 4th b to the 3rd in all in parentheses times a to the 2nd b to the 1st. So whenever you don't see the exponent, it is understood to be 1. Alright? So now, this is multiplication, and the law whenever you're multiplying is that you're going to copy the base. So now you will have an a, and you will add their exponent, meaning to say that's 4 plus 2, that will be 6, and for the b, copy the b, and you will have 3 plus 1 will give you a 4. So that is pretty much D. Second example for objective 2. This is 5a times a to the 4th in parentheses with an exponent outside. For this example, guys, we're going to use the order of operations GEMDAS, starting with the G, which is grouping. If you'd look at this, there isn't really any grouping, but the next one is exponent. So because of that, we're doing this exponent first, and that exponent is the law of power of powers. In the rule of exponent, whenever you have power of powers, you're going to multiply those. Meaning to say 4 times 3 is going to become 12. So after you multiply the 4 and the 3, which will become a to the 12, you're going to copy down 5a on the side, and then you're just going to multiply it. Multiply the coefficients first. You know that there's a coefficient here of 1, so 5 times 1 will become 5. Okay, and then a times a12, you know that there's a 1 there. So therefore, we're going to apply the law of multiplication, which now says that you will add your exponent. We need to say copy the base, and then your exponent will turn to 13, and your answer is B. So now we go to the next example, and this time it is dividing. Please understand that when you're multiplying, you're adding the exponent, but when you're dividing, you're subtracting the exponent. Which is why here now I have a to the 3rd power, because that's a 5 and that's a 2, and 5 minus 2 is a 3. Let us now go to this one. We can do this in 2 ways. We can have b squared minus negative 2. That minus negative 2 that I talked about was here, because whenever you're dividing, the rule is you subtract exponents. So copy the base, and then this 2 minus negative 2. And if you operate on this, this will give you a 4. Or, whenever you have a negative exponent, for you to turn that into a positive, if it's down in the denominator, you will have to bring it up in the numerator so that it becomes a positive 2. If it's in the numerator and it's negative, for you to make that negative become a positive, you will have to bring it down in the denominator. So vice versa. This 2 will give you the same exact answer. So here, the answer is a to the 3rd, and then for the b, add the exponent, b to the 4th. Here, a to the 3rd, and 2 minus negative, double negative means positive. Therefore, that is going to be a positive 4, which will give you letter B. Okay, last and final example for objective number 2. So you have this coefficients right here for the numerator and the denominator. You're going to simplify this, and the greatest common factor of 18 and 10 is 2. Therefore, that is going to be 9 out of 5. You have Desmos as your tool, so you can also do 18 divided by 10. And Desmos will simplify it for you. 1.8, that is in the decimal, but if you click on this side, it will give you the simplified version, which is 9 divided by 5. For x, we have x to the 6 on top and x to the 2nd power below. You subtract them. 6 minus 2 is x to the 4th, and that x to the 4th goes on top. And the way I explain this is because this has more, so your leftover will be where it is more. So 6 minus 2 again is 4, and the leftover goes on top. For here, y to the 7th and then y to the 9th. If I subtract 7 minus 9, it will turn into a negative 2. But that's negative, so you will have to bring it down in the denominator. If you don't understand that, then just do this. Where is the leftover if you have 9 and 7 here? So 9 minus 7, that is a 2. And where will the leftover be? The leftover will be here at the bottom because it has more. And then for our last one, z to the 0, any number raised to a 0 power is equal to 1. So that means times 1. And anything multiplied by 1 is the number itself. So therefore, your answer is C. Okay, last and final objective. I can simplify numeric and algebraic expressions using the laws of exponents, including rational exponents. In this example, we are going to apply the power of powers, which means that you will multiply this power inside with the power outside. So 3 times 1/3 is going to turn to a 1, so that's going to just be 8 to the power of 1, which is 8. We are going to check decimals and see if that comes out correct. If you use your decimals, it will concur, and the final answer is letter A, which is 8. For this next example, so 125 raised to a negative 2/3 power, we can just exactly put it in on decimals as you can see here and get the answer. So that could be your answer, and if you want that to be in fractions, click on this side and it will be 1 out of 25. This is another way of showing your answer. Since the exponent is negative, for that to turn into a positive exponent, that needs to go to the denominator, and so your answer could be 1 out of 125 to the power of 2/3. But there's also another possible answer as well. So this is another way of showing it. The denominator of your exponent is your root. So this is actually your cube root. You're looking for the cube root of 125, and once you get that cube root, you're going to square it. So the numerator is going to represent the exponent, and the denominator is going to represent your root, whatever you're looking for. If I plug this in on decimals, we're going to get the same answer. So I'm going to show this to you. 1 divided by, you're going to click on functions under miscellaneous, this one right here. You're going to click on cube root, and then inside you will type 125 close parentheses power of 2. Okay, here you go. So again, this next example, I want you to plug it in on decimals. So after plugging it in on decimals, we see this decimal, and that is the fraction. Now we have another way to show it, which this, since your exponent is negative, for it to turn to positive, you are going to put this in the denominator, showing this. And then, okay, with the radical, this is how it looks like. 1 over 4th root, so the denominator is the root, 4th root of 16 to the power of 3. If you plug this in on decimals, you're going to get the same exact answer as 1 out of 8. Once again, to turn this decimal into a fraction, you click on the side and it will give you the same exact fraction. So last and final example for objective 3. So on here, the rule that you're going to follow is power of powers, which you will multiply the exponents inside with the exponent outside. So that means 4 times 1/2, that will be 2. 8 times 1/2, 4. 6 times 1/2, 3. Making it become letter D. So that is it, guys, for our workshop on exponential operations. I hope that you have learned a lot today, and good luck in taking your power focus assessments.